Hello everybody, this is Juan. In this video, I'll be showing you how to add a new overlay state into ALS. As an example, I have added the dual sword kit animation asset pack into an out-of-the-box ALS blueprint project. The things I'll be doing in this video are, I'll be briefly showing you how to retarget these animations into ALS, but I'll not be explaining that in depth. If you're unsure about retargeting, I recommend you to check a video about this topic to know more about it. The second thing I'll be covering is adding a new overlay state in depth for the weapon and configuring the anim curves for it. And lastly, I'll be adding a full body attack animation as well as a half body attack animation as some examples on how to further implement animation packs into ALS. Something that I will not be covering in this video is overriding the locomotion animations of ALS. If the animation pack you want to apply to ALS has a very different set of locomotion animations, I recommend checking my other video that talks about overriding the ALS locomotion animation assets to make the character walk different when it carries a certain weapon or item. So I'll quickly go ahead and retarget this skeleton. So the first thing we must do is add an enum. To do this, open the ALS folder, go to data, enums, and open the ALS overlay state enum asset. Add a new entry. In this case, will be dual sword. And then head over to the anim blueprint. Go to the overlay layer animation layers, or you can click on anim graph and click on the overlay layer linked anim layer. Open the overlay state machine and right click on the graph to add a new state. We'll name the state after our newly created enum, and we will connect it both ways. Now the one going into dual sword, we will change the blend logic to initialization. You don't need to do this for the one going out since it's going out to a conduit. Now we change it to initialization, and you can also add change different settings. I recommend the initialization blending not only because the rest of the default states use initialization, but also because the inertial blending itself is more natural as it uses velocities and momentum instead of position blending. So once we have that, open each transition rule and add the appropriate check. In this case, when it's going to dual sword, the overlay state has to equal the newly created enum, and when it's going out, it has to not equal that. Okay, so once that's done, open up the dual sword overlay state and you will notice that it expects an output animation pose. For testing purposes, I'll just play the anim idle animation and see what happens. As you notice, if I change to the dual sword overlay state, nothing happens. And this is because the anim idle doesn't have any curves indicating how to blend this overlay state into the locomotion. So first thing I would do is instead of using this idle pose directly, I'll create an asset. I will create an animation based on the current pose, and I'll place it in a different folder. indicating that it's for the purposes of ALS. So once I've created the idle pose single frame animation, I'll place it here. I recommend you to change this to a single frame animation and have an explicit time, simply because you can modify the curves at different times and have different behavior on the layer blending phase, so that you have different outputs with the same animation asset. So currently I'll just leave it at 0 and test it out. So you can see it's the exact same results. And that's because we haven't added the animation curves yet. Before you add the animation curves, you need to think about what things you want to bring into the table. So what things you want to show from the pose and what things you are okay for the locomotion to keep using. And you can have a mix in between because it's a blend. So in this case, for the idle pose, I want the whole body to be shown. So in this case, I will be adding all the layering curves that have to do with the actual blend. So the arm L, arm R, hands, the head, legs, pelvis, and spine. And I'll be putting all those to a value of 1, which means that you want to fully blend each of the parts. Once I have all the layering curves set to 1, I'll go ahead and test it out. As you can see, now it shows the idle pose, although it looks a little bit static. It doesn't really move that much. The reason why the legs are still moving is because the out-of-the-box ALS project has the additive set to 1. So even if you're overriding the legs fully, the additive of the locomotion still is being applied to the legs and the pelvis. So when you move, the legs will still be moving as well. Now go ahead and add an additive node as well as the ALS secondary motion additive so that you have a breathing animation as well. Now the breathing animation can be a little bit too intense right now, so I'll just reduce it by 50%. Personally, it looks more natural like this, but you can definitely have like an energy point system where depending on how many energy points you have, it becomes more exhausted and breathes with more intensity. You can also adjust like the play rate here so that it starts breathing even more intensely and faster. Seeing how the idle pose looks like, I'm quite satisfied with the result. Well, now if I start moving, the movement has more motion than the breathing. So now the final pose, the upper body part, looks like it's static while I move. So I want to have a little bit more movement on the upper body while I run or walk. But before I do that, I'll actually, instead of using the idle pose, I'll use the running pose for this one. The running pose looks like this. And what I'll do is similar to what I did before, which was create a current pose animation. Once I've created the run pose, I will go back to the dual source state and I will have to basically juggle between the idle pose and the run pose, depending on if the character is moving or not. And the way I do that is via a blend between idle to run, and the alpha value will actually be an animation curve. This animation curve, if I click play and I press I, the I key, to show the anim curves, you will notice that there's a curve called weight gait, which indicates whether the character is idle, walking, running, or sprinting. If the weight gait value is 0, then that means it's idle. If it's 1, as you can see right now, if the value is 1, then that means it's walking. If the value is 2, it means it's running. And if the value is 3, it means it's sprinting. So we can use this weight gait curve to determine if we are moving or not. And what I'll do is I'll clamp the result, simply because the weight gait, it's called weight gait, not weight curve. And I'll clamp it between 0 and 1, simply because the weight gait can go over 1, and we would like to keep the values between 0 and 1. Okay, once I do that, you'll notice that when I start moving, it starts going back to the original locomotion. The reason is that we haven't added the animation curves yet. Before adding the anim curves, you need to think about the parts you want to blend. So in this case, in this pose, we would want to blend the upper body. The lower body is similar to the locomotion, so we will leave it as is and just blend the upper part. So in this case, I will be adding the left arm, the right arm, the hand L, hand R, the head, not the legs, not the pelvis. I would like to add the spine as well. And I will set all of these to 1. Once all of these curves are 1, I'll go ahead and play once again. And you'll notice that now the curves do take effect and make the whole upper body blend into the running pose. However, right now it looks very static. You'll notice that if I start running, the spine doesn't really take that much of a influence from the run. If I run with another pose, you'll notice that the spine moves significantly as we start running, as we start accelerating. So we want to have something similar for this pose. And there are a few anim curves for this. And the anim curves are called the additive anim curves. All it does is, instead of just blending, what you do is also apply an additive of the locomotion into the overlay state. Most of the time you would want to think about using additives when you want to bring part of the locomotion into play. So in this case, I'll just put it as 1, the spine, and test only the spine currently. So you'll notice that the spine is much more responsive now, but it's leaning forward too much. And the reason being that we are applying the additive between the spring pose and the standing pose, which means that it'll be a leaning forward pose. We're applying it to a pose that is already leaning forward, causing the final pose to be leaning even more forward. So what you have to do in this type of cases is consider how much of these two you want to use. So if I use 0 here, that means that I will use the locomotion spine instead of this spine. So if I say 0 here, looks more natural, but there's another option. You can go ahead and instead use half of it, half of this spine, and then half of the additive from the locomotion. Something you might also notice is that when I am moving, the arms seem to be unreactive to how the spine is being like rotating left and right. And the reason is because everything usually blends with the mesh space rotations instead of the local space rotations. For the arms, in this case, we want the arms to be influenced by how the parent bones, in other words, the spine, rotates. So we want to add an additional curve for the arms, and these are called arm LS and arm RLS. The LS means local space. So if you put this to 1, that means that it'll be using the local space. If this is 0, then that means that you will be using the mesh space, and anything in between is a mix between the two. So as you can see, now the arms are moving left and right with the spine. But I don't want them to become too much of an influence with the spine. So I'll just have I'll just put at 0.5. So that means that I will just take 50% of the local space rotations and 50% of the mesh space rotations, and I'll just mix them so that we have a much more natural, I believe, result. You'll notice that when I start running with the default overlay state, the arms swing back and forth, and I want to give that just a little bit of an influence. I want the arms to be swinging a little bit back and forth, not too much though, when running in this position. So what I'll do is I will use the same thing as I did with the spine and have some additives for the arms as well. Now I'll just have a subtle difference. Maybe I gave it too much, but I'll just test it out. And as you can see, it swings back and forth, but it's a little bit too much. So I'll just put this at 0.05 for now and test this out. So you'll notice that the swings are much more subtle, and I think I'm happy with how it looks. We have added the additives for every part of the body, the upper body, except for the head. You can just go ahead and add it and test it out if you like it or not. Another thing that might be a little bit concerning in the current state is when switching between the two states, between running and idle. See that the blending between the two depends greatly on how the weight gate blends to 0 and to 1. So I don't want to be dependent more on how the weight gate is blended, but rather have a slower blending. And the way to achieve this is to go back to the dual sort overlay state, and in the blend node I will select the interp result, which means that whenever this value changes, it doesn't change immediately, but rather it interpolates that value depending on the speeds here. If the value is increasing, the speed will be 10, and if the value is decreasing, the speed will be 10. In this case, I'll leave it as is and test it out. Now, something we haven't talked about yet is when dealing with jumping. If I am idle and I jump, it looks, can look normal. I don't really like it that much, but the upper body seems to be a little bit static. But the problem comes more obvious when you start running and then you jump. For some reason, when I start running and I jump, it goes back to idle even though I'm still moving. So the reason behind this is, if you notice, when I start moving, the weight gate is 2, if I walk is 1, if I sprint is 3, but as soon as I jump, this weight gate value goes to 0, and a new curve called the weight in air is added and becomes 1. That means that whenever we are jumping, the weight gate becomes 0, so it starts using the idle pose. One way to change the way the jump looks is have another blend node, and this time use the weight in air curve to determine if we want the ground state or we want the air state. For testing purposes, I'll just use the run pose so that we know that it should no longer display the idle pose when jumping, but rather the run pose, even if we're idle. So now, as you can see, it starts using the run pose in the air. So what to do when you want to use the idle pose when you're idle and the run pose when you're running when jumping or in the air? Well, what you do is use another blend here, blend by bool in this case. And there's a variable called is moving. So if it's moving, you want to use the run pose. If it's not moving, you want to use the idle pose. Again, there are a lot of variables that you can use depending on the situation. For simplicity, I'm just using the is moving boolean, but definitely you can have a lot more checks here and different logic to determine which type of pose you want to use. So as you might notice here, there are a few extra parameters, and what this indicates is that instead of snapping between the two values, when this variable changes, you blend between the two. So in this case, I want to blend, I want to make the blend time a little bit longer and change the blending type to initialization so that it uses initial blending to make the transitions more natural. As you can see, the jump is using the run pose when running, and when I'm standing still, it uses the idle pose. I still, though, think that there are a few things to change. So one of the things is changing how the body reacts to the jump. In the default locomotion, you will notice that the arms move. So I want to have some additive into the arms. So I'll start off by first editing the idle pose. But before I do that, please remember that we're using the same asset here in the grounded and the air. So we need to use different curve values when in the air. So what I'll do is, instead of using the asset at time 0, I'll use the same asset but at time 0.02, and it can depend on how long this animation is. In this case, this animation is 0.03 seconds long, and I'll use the anim curve values found at this time frame at 0.02 second time. So I'll go ahead and add the arm additive curves. I'll make sure that the values at time 0 are 0, and I'll switch off time snapping and make sure that something just before the 0.02 mark is set to the value that I want the additives to be at. So I'll change these points to be constant interpolation, simply because if I change this to 1, I don't want the values in between to be interpolating, but rather absolute. So I'll just change this to constant. So if I am at the 0 mark, it will use 0 additive on the left arm. And if I am at time frame 0.02, I'll use the additive for the left arm at 1. But in this case, instead of using 1, I'll probably use 0.25, because I don't want it to be influenced that much. And I'll store this curve and I'll apply it to the right arm additive so that we have the same exact curve in both arms. So I'll go ahead and test this out. And you'll notice that when I jump, it receives a little bit more of a influence from the jump. I will also add a spine additive as well. I'll apply the same exact curve. Play. Just in case that we also have a head additive, we'll also apply the same curve. So notice it's way more natural, but once again, I really don't like how the jump changes from moving the arms to suddenly being static. So I will just change this interpolation to use interpolation, but only when I'm landing. So what this means is that when I'm landing, the weight in air will start decreasing value. So I'll have interpolation speed, but when I jump, I want that to be almost immediate. So I'll leave this as 0 and test this out. The transitions look way more natural. And I'll do the exact same thing that I did with the idle pose with the run pose. So with the run pose, we already have the arm additives, and it's just a matter of adding the value we want to add at the 0.02 time frame. So in this case, I'll probably do 0.02, 0.25 as well. I'll store the curve and apply it to the arm. Probably to the head. Well, the head is already 1. The spine additive is 0.5 already. So I'll leave it as is. And change this time to be 0.02 so that we start using those anim values and hit play. So as you can see, when I jump, receives that jumping, like arm swinging animation, and we apply it to this running pose as well. Although I think it's just better to reduce this a little bit, have it less of an influence to the arms. The standing states seem to be in order, but if we try to crouch, we're not able to crouch. And the reason being that we haven't, or our curves rather, are not considering the crouch. And all that we need to do with the crouch is consider how the pelvis and the legs behave. You can also consider the spine as well, but first let's deal with the legs and pelvis. So what I'll do is I'll grab this same idle pose, and I will, at the 0.01 mark, I will modify some of the anim curves. So in this case, the legs, I want them to be 0. The 0.05 mark, I want them to be 0. And then once again at the 0.015, keep it as is for the jump. Change this to constant so that I can have a better look at how the values change. Store this and apply this same thing to the pelvis. So when I'm at the 0 mark, I'll use the legs as 1, pelvis as 1. When I'm at the 0.01 time frame, the legs will be 0 and the pelvis will be 0. And then at the 0.02 mark, it'll be 1 and 1 as well, the same as 0, 0. So I'll go ahead and change this to 0.01. And I'll do a blend once again. Now this blend will be similar to how you blend in the base poses. So we have the base pose end variable and the base pose CLF. And when it's this pose 0 would be the end pose, so the standing pose, and the pose 1 would be the CLF pose, in other words, the crouching pose. So when it's standing, you want to use this, and I'll change this to grounded standing. Select it here. And this will be grounded CLF. And change this from standing to N so that we maintain consistency with how ALS describes this stance. Currently, ALS only has the standing, so N, and the crouch with the left foot, so CLF. But in the case of having multiple base poses like proning or crouching with the right foot, you might want to keep using the blend multi. You might want to be inclined to use a blend like this one here, but I don't recommend it simply because of the possibility that there will be different poses in your project, not only standing and crouching. So let's go ahead and play and see how this looks like. You'll notice that now the crouching works properly. And if I try to walk, it looks a little bit weird. So we might want to add a little bit of additives in this time frame. So once again, I will turn off the snapping and at the 0.05 time frame, change it to constant again. I'll store the curves and apply it here, here, and here. And you'll notice that just by looking at the whole curves at once, you'll notice how each time is different from the other. So let's go ahead and play once again. And you'll notice that the walking is more natural. So looking at how this overlay state looks in all the states, crouching, running, jumping, idle, I think I'm pretty satisfied with how it looks. Now, so far, there's one issue with the new overlay state we added, and the problem is when doing low mantling, it gets stuck. There's a lot of errors that appear, and when trying to roll as well, I'm not able to do so. I'm able to do it in other overlay states, but not in the current overlay state, and the reason I will explain it after I add a full body attack animation and a half body attack animation. I'll be adding this full body animation into ALS. So when I press the attack button, I want this to be played. So I'll add some temp logic so that I can be able to play it when I click the left mouse button. If I play the attack montage, you'll notice that it doesn't appear. Only the root motion data seems to be carried over. And the reason for this is because we're playing the animation in the default slot. And in the out-of-the-box version of ALS, the default slot is not used. So what we need to do is change the montage slot to the slots, one of the slots that is used in ALS. For full body animations, I recommend using the movement action group base layer. And the reason for this is that it overrides all the locomotion logic and is passed on as the base layer input. So if I go ahead and click play, you'll notice that the animation does appear now. Looks a little bit weird. Some artifacts appear, And the reason for this is because we have overridden the animation, the locomotion here, but in other parts of the ALS blueprint, we use the anim curve values like the base pose N and the crouch. So when I press I and I'm checking the anim curves, you'll notice that there's a base pose N curve, which means that when it's at 1, it's standing. When I'm crouching, the base pose CLF anim curve comes into play and it becomes 1, and the base pose N becomes 0 and disappears. But when I play the montage, both disappear and there's absolutely no anim curves present. Which shouldn't be the case. So the first thing you need to do when dealing with montages being played in the movement action group base layer is determining whether this montage is for the standing base pose or for the crouch base pose. Of course, if you have other base poses like proning, you will have to consider that as well. So in this case, since the attack animation is a standing animation, I will use the base pose and anim curve and set it to 1. I'll test it out. You'll notice that there's no more snapping, although there's some issues with the whole body itself. You'll notice that the upper body is using the idle pose. And the reason for this is because when we play the animation, the layering anim values are still present. And therefore, when we get this base layer, movement action group base layer animation that is being played from the montage, it's carried over and into the layer blending where the blending happens. So when you play an animation montage with the base layer movement action group base layer slot, that doesn't mean that you skip the layer blending. That only means that you're skipping the locomotion part. So what we have to do is, if you want a full body animation with so no interruptions or no blending at all, what you have to do is add the layering curves. Just in case, I will also add the hand curve and set this all to -1. The reason why it has to be -1 is because the curves from the locomotion or from the base layer are blended with the curves from the overlay states. So when they're blended, when one of them is 1 and the other one is -1, they cancel each other out, which leaves it at 0. So you will not have any layering taking place at that body part. So we're putting all of the body parts at -1 so that we are canceling all the layer blending and playing this full animation without any blending taking place. Layer blending. So as you can see, now the montage is played correctly. And even though I am blending, I try to blend the arms with the current pose in the overlay state. When I play the montage, as soon as I play the montage, the layering arms become 0, and the whole montage is played correctly. Something you might also want to consider is adding the foot IK curves and going from 0 to 1 depending on whether you want to use the foot IK. The reason why you don't use -1 here is because the foot IK is calculated in the locomotion part. So all the layering curves need to be either -1 or 0 here, but the non-layering curves are to be handled, from 0 to 1. So in the case of foot IK, the reason why I won't use IK here is the animation itself is not correct. It doesn't have the IK bones. So if you move these IK bones should be moving as well, but they aren't. So if I turn the foot IK on, the feet will be stuck on the ground. It's something we don't want. So I'll leave it as, I'll remove it and leave it as 0. The foot IK would be useful when you're trying to play the montage on slopes or on non-flat surfaces. And the foot lock you might also want to consider when the montage is finishing or like standing still. The reason for this is that once you finish the animation, you want the feet not to be sliding, but rather adjusted naturally by the character and not having it like blend and slide back to the overlay state or the original place it was in before. So in this case, if I play it right now, you'll notice that the feet end with a slide. I don't recommend this, but because like I said, the current state of this animation is not, with this current state of the animation, it's not possible to deal with both foot locking and IK, because foot locking depends on IK. But if it was a normal and correctly coded animation, I would put the foot locking probably here for the left foot. And go to 1, this landing. And for the right, probably here should be landing. Something like that. Timing should be similar, but of course, need to test this out. As you can see, that the feet no longer slide. That's because we didn't move it in the first place. But with this type of logic, you will have something um, something similar where the feet don't slide, and instead it adjusts the position of the feet in a more natural way. Something that you might want to add to this montage is the mask footstep sound curve. And what this does is not let the footsteps of the locomotion be played, since the footsteps here can be played at a different rate. And so you might want to call the footstep here when the first footstep is, when you place a footstep like here, you might want to call the footstep anim notify and click on override mask curve. What this will do is that when you call this, instead of checking whether the mask footstep sound is 0, when it's 0 it means that you can play the sound, when it's 1 it means that it's masked, or rather blocked. But if you have this on true, then it will not use that check, and it will play the footstep sound regardless. And when you play, you will see that the sounds are more natural and will not be able to follow the locomotion's sounds if they are played. So now that we have a full body attack animation, I'll go ahead and create a half body, an upper body attack animation. So the difference between full body animations and upper body animations is that full body, you don't have to consider the locomotion being calculated and just play the montage. But in the upper body animations, you have to have the lower body to use the locomotions. So the locomotion is calculated in the base layer. And so we cannot use the movement action group base layer slot, because that slot overrides the whole locomotion logic. What we instead need to do is use the layer override group slots. And similar to how we added the anim curves, we need to think which layering slots we want to add, which depending on like what type of body part we want to add. So in this case, we will add the whole body, the whole upper body. So we'll start with the spine, duplicate it, add the head, the arms, and finally curves. What's so special about the curve slot is that managing or calculating what the curve values are for each part can be very tricky when dealing with this complex uh, layer blending. The fact that the anim curves come from the locomotion, the overlay state, and the montage you play for each part of the body makes things more complicated. So instead, what this last part does is take the locomotion anim curves and blends the anim curves found in the overlay layer, but obviously you can override it with the curve slot and blend them together and then override them here. What this logic is useful for is, for managing the curve values in a more direct way. So adding this when dealing with layering override group slots is what I consider essential. So in this case, we will add each body part and their corresponding anim curves. Now, if I leave them as 0, obviously nothing happens. So we want to place them as 1, no additive for now. We want the animation to play as is on the upper body, so no additive. The arms as 1. The arm are as 1 as well. The hands. And Let's play it now. You'll notice that it kind of snaps, and where it starts to snap is in the pelvis area, and the legs snap a little bit. So what this means is that the current overlay state is trying to use the legs. So what we're doing is also setting these to 0, even if we're not using them, simply because we need to explicitly mention that we are not using that part, even if it's not here. So now, as you can see, we will be able to move around while playing the upper animation. The spine moves a little bit upwards when sprinting. You can add the spine additive, but you want to keep it probably straight, simply because the slash should be pretty much horizontal, or the direction the animation is in. But it depends on what you want to achieve or accomplish with this upper slot animation. So yeah, I'm currently satisfied with how the full body animation and the half body animation are played. The full body one once again. The half body one. Finally, I'll be talking about movement actions. So for a default overlay state, you can roll, you can mantle, and when you switch from the ragdoll, it gets up either way. But if I try to do this same thing with my new overlay state, these actions will not happen. For example, I'm trying to mantle here and it got stuck. There's a lot of errors that occur. I try to roll and I can't. So the reason this happens is that I haven't specified the assets I will use for these actions inside the character blueprint. So for the ragdoll system, there's this GetUp animation, which you will have to specify which type of settings you want for the dual sword for our new overlay state. Then there's the get mantle asset and the get roll animation. So all of them, as you can see, have a missing link, which is our new overlay state, and we'll have to connect it to a new setting. So I'll start with mantling. If I open up the default mantle montage, I notice that the anim sequence being used is the RH mantle anim sequence. If I open the 2H anim montage, you will also notice that the anim sequence is the same, and the RH montage will also have the same anim sequence. The only difference between the three are not only the notifies, but also the anim curves, and the anim curves is what makes it look different. So in the case of default, the default shows the whole body. So this is played full body as is. As you notice, as we did in the full body attack animation with dual sword, all of the layers are set to -1, or are blended here to -1. And then back when it stands up to 0, so that if you have an overlay state that has layers to blend, then to blend it before it fully stands up. In the case of RH, you'll notice that only the RL is being set to -1 and there's no arm R being set. And the reason for this is because this RH montage is for overlay states that have an important arm R. So in other words, they cannot play the arm R part for this montage. They have to keep that overlay state arm R pose. Similar with 2H, instead of just only the arm R, you have both arms that are not here. And that means that the arm R itself is too important. Both arms are too important to block when the layering comes to play. So in the case of the dual sword, I will use the default mantling. It doesn't look bad. But let's see if we can do better. So in the case of RH, let's see what we get. As you notice, it's this on the left. For the left arm, it's the same, and the arm R remains fixed, but the arm R looks a little bit strange because of the right arm overlay state being blended in. And the reason for this, if you look at the curves, the arm LS becomes 0, so the local space is not used, and only the mesh space part is used. What I would recommend is going to the AnimBP, going to the idle pose, and adding the LS since we didn't add it before. Set it both to 1. And you'll notice that now it's way more natural. Okay, now that we have done mantling, let's move over to roll. With the roll, we can keep using RH, but I believe that in the case of rolling, the default should look perfectly fine. I don't think there's a reason for us to keep the rolling fixed to an arm, simply because both arms are too extended away from each other, and rolling with one of the arms extended will look a little bit strange. For ragdoll, I think as well I'll just use the default, since I don't think it's the keeping the right hand is gonna be too important. So it stands up with the right hand. Oh, I think I made a mistake here. GetUp front default is the one we should be using. So it falls front, stands up properly. On the back. So I think both are working. And so far, these are the 3 actions that are used currently in ALS. Obviously, if you have more actions in your system, you have to add them as well. You have to consider having a different system, because updating it like this might be a little bit prone to bugs and null pointers. Well, that is all. If you have any questions or ideas of what to do next, please let me know. I hope you find this useful, and I'll see you guys next time.